Jai Hind to all of you. Today I am going to record one topic of digital electronics unit or fundamental of electronics engineering, that is a subject of first year engineering course, and in this video I will cover the minimization technique using KMap. In this video I am going to cover the following topics, that is what is KMap, how we use the KMap to minimize Boolean expression, and then we use KMap for 2 variable, 3 variable, 4 variable, 5 variable and up to 6 variables. First of all, what is KMap? KMap is a minimization technique which is developed by Maurice Carnot in 1953. It is basically a map method for synthesis of combinational logic circuits. It provides simple, straightforward procedure for minimizing Boolean expression that may be regarded as a pictorial form of truth table. KMap order and displays the min term in a geometric pattern which is like a matrix and apply the logic adjacency theorem to minimize Boolean expression. It is a diagram made up of squares and each square represents one min term or max term. Min term basically corresponds to SOP form and max term corresponds to POS form. Since any Boolean expression can be represented in terms of sum of min term, that is called as sum of product form or product of sum form, POS. So, any Boolean expression which can be expressed as SOP or POS form can be recognized from KMap, that is map method, by the area enclosed in the squares. By various patterns, we can derive the alternative algebraic expression for the same operation and we can select the minimum or simplest one. Now, regarding the steps to draw the KMap. First of all, draw the KMap based on SOP or POS form. If we consider the min term expression, then enter 1 in the squares corresponding to the min term, for which function value is 1. If we use POS representation, then we enter 0 in place of 1 for each max term in the corresponding expression. Now, the following steps are used, that is examine the KMap for squares and find out whether there is a pair or group of 4 or 8 ones or zeros in the KMap. So, if there is a pair of 8 ones, it is called as octet. If there is a pair of 4 ones, it is called as quad, and if there is a pair of 2 1, it is called as pair. Now, we group these ones or zeros in the order with highest priority to octet. Then we say if there is no octet, then we go for search for quad, and if there is no further quad, then we search for pair. In this order, we use KMap to group the number of ones or zeros, and we omit any redundancy in the grouping. Now, we use the logic adjacency theorem to group these squares and minimize the expression. If there is a group of 2 squares, we eliminate one variable from the equation. Similarly, if there is a group of 4 squares, we eliminate 2 variables, and if there is a group of 8 squares, we eliminate 3 variables. Now, what is SOP and POS form? SOP form is also called as min term expression. Min term expression, that is it sum of product term. Each literal is in the product form and we add the whole product term, that is sum of product form. It is basically OR operation of AND operated variables, and each sum term, each SOP term, that is each product term, is entered as 1 in the KMap. Similarly, for POS form, it is basically AND operation of OR operated variables, that is each term is sum form and the overall equation is the product of each sum term, that is product of sum term, and each term is represented as 0 in KMap for POS function. So, either we enter the values in SOP form or POS form in KMap. Now, starting from the very simple or smallest size of KMap, that is 2 variable KMap. The smallest sized KMap is of 2 variable because it is not possible to minimize a function of single variable. So, for a 2 variable KMap, we make 2 by 2 square, that is a square of 4 values. One variable is taken on the left side and the second variable is taken on the top side, and it will form a 2 by 2 square. As each variable has only 2 values, 0 or 1, so zeros and ones are mapped on both the sides, and by this 0 0, that is min term 0, 0 1 min term 1, 1 0 min term 2, and 1 1, that is min term 3. So, accordingly these min terms are entered in the KMap. Now, we take one example of min term expression, that is 2 3. As the highest value is 3, so it is a 2 variable KMap. We first of all form the KMap by taking A variable on left side and B variable on top side. Then we enter 2 and 3 as 1. First variable is A bar B bar, that is 0, A bar B 1, A B bar 2, A B, that is 3. So, 2 and 3 are entered as 1 and other 2 are 0. As we can see that there are only 2 ones, so there is no possibility of quad or octet. Then, so we search for pair. Pairs are formed either vertically or horizontally. We will not form any group in diagonal fashion. So, there is a horizontal group, that is a pair. When we see on the top and left side, from the top side both B bar and B comes in the expression, which will make B plus B bar, which is equal to 1. So, it will eliminate B variable from the equation. As we can see from the left side, there is only one variable A, so y is equal to A. So, this is the final form of our minimized expression. So, again I will tell you the steps. Once the min term expression is given, first we will find out the size of KMap by checking the highest term. As it is 3, so it is a simple 2 variable KMap. Then we draw the KMap and enter the values given in min term expression as 1. So, 2 and 3 are entered as 1. Now, we form the pairs or groups, as there is only one pair, and next we find out the expression by checking on the top and left side variables. If a variable and its complement both comes in the expression, then we cancel out that variable, like as B and B bar both are in the expression, so we cancel out B, and in left side only A is present, so we find out that the final expression is y is equal to A. One more example we can see, min term is given as 1 2 3. So, again we form the KMap. As highest variable is 3, so it is a 2 variable KMap. Again A on the left side and B on the top side, 1, 2 and 3 are entered as 1. And now we see that there are 2 pairs, one from the horizontal and another from the vertical. Point to be noted here is that we cannot prepare any group in the diagonal fashion. Only vertical or horizontal pairing is done in KMap. Now, again for horizontal group we check from the left side, it is A, from top B and B bar will be cancelled out. So A, and from the vertical group A and A bar will be cancelled out, and from the top side it is B. So A plus B is the reduced expression. Moving towards the 3 variable KMap, for a 3 variable expression, the maximum is 2 to the power 3, that is 8, that is the value goes from 0 to 7. So the min terms are M0, M1 to up to M7, and for these min terms the output will be Y0 to Y7. So we take one variable on the left side and 2 on the top side, or vice versa. We can also take 2 variables on the left side and 1 on the top side. Anything can work for the same. So if we take 2 on the left, then it is 0 0, 0 1, 1 1, 1 0 and 0 1. So it comes out to be M0, M1, M2, M3, M4, M5, M6 and M7. And if we take on the horizontal fashion 0 0, 0 1, 1 1 and 1 0. One thing here important is that the order is in the gray code fashion, not in normal binary. That is first 0, then 1, then 3, then 2, because we want only one variable change in each consecutive expression. From 0 0 to 0 1 only one variable change, then from 0 1 to 1 1 only one variable change, from 0 to 1, and then 1 1 to 1 0 only one variable change. So it is mandatory in KMap designing that for each consecutive step only one variable will change. So we always write the variable in fashion of gray code, not in simple binary terms. So this is the format of a 3 variable KMap. Now we will take one example of again SOP form, that is 3 variable KMap. We will take an expression 2 4 5 6 7. The largest variable is 7. By this we find out that it is a 3 variable KMap. Now we will prepare the 3 variable KMap by taking 2 variables on the left and 1 on the top side. 0, then 2, 1, 2, 3, 4, 5, 6, 7. Now we enter 2 as 1, 4, 5, 6, 7 as 1, and all the remaining terms are 0. So first of all, we will check will there be any octet. As we can see that there is no octet, then we search for quad, and we have seen that there is a group of 4 ones, that is a quad. No further quad is there, then we search for a pair, and there is a group of 2 ones, that is a pair. So one quad and one pair is there. Again we search for the equation in the same way, like for this quad we take 2 variables from the left side. B and B bar is there, so this will be cancelled out. A and A, so A will be written here as it is. From the top side C and C bar, so C will be cancelled out, so only A will be there. Now this pair, from left side A and A bar will be cancelled out, B written here, then from top side C bar, so the final expression is A plus BC bar. So I hope the 3 variable KMap is quite clear. The first step is to identify the size of KMap by checking the highest number in SOP term. If it comes in the range up to 7, then it is a 3 variable KMap. Then we input the number of ones in KMap as given in SOP form, and then find out the group starting from octet, then we search for quad, and then last is pair. If there is any redundant group, then we omit the redundant group, and then each group will be converted to the final min term expression form. Now moving towards the most widely used equation, that is 4 variable KMap. For a 4 variable KMap, as we can see that for a 4 variable 2 to the power 4 equal to 16, that is the value goes from 0 to 15. So for any SOP equation, which consist of term greater than 7 as less than 15 up to 15, then it's a 4 variable KMap. And for 4 variable KMap, again it's a square pattern. 2 variables will be taken on the left side and 2 on the top side. And we will always start from MSB to LSB. Here A will be most significant bit with highest weight and D will be least significant bit with minimum weight. If we change the weights of variable, that is A, B, C, D will be converted to D, C, B, A, then the KMap will also be changed accordingly. So always the first variable on the very left side will be a variable with highest weight and the last variable on the rightmost side having minimum weight. So it is always from MSB to LSB. Again same variables 0, 0, 0, 0, that is min term 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we form the 4 variable KMap and the terms which are given in the equation will be inputted as 1 and remaining will be inputted as 0. So as we can see, the highest term is 14, so it's a 4 variable KMap. We take 2 variables on the left side and 2 on the top side, considering A as MSB and D as LSB. Now the term which are given as 1 are 0, 1, 2, then 6, that is 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7. So 6 is entered as 1, then 8, 9, 10, 11, 12, 13, 14, 15. So the given terms will be entered as 1 and then we search for first of all octet. As we can see from the entire KMap that there is no group of 8 ones. So there is no octet. Next we search for quad. There is one quad from this vertical group and one quad around 4 corners. We can consider it as a taking a square handkerchief and when we fold it 2 times, all the 4 corners come at the same position. So all the 4 corner ones will form a group. So there are 2 quad and now we search for pair. So there is a single pair and this one will not group from any other variable because there is no adjacent one around this one. So it will treat it as a single variable. Now we write the expression for this vertical quad. As we can see from the left side, A bar and A both terms are there, it will be cancelled out, and B bar and B both are there, so B also will be cancelled out. So we will take only C, D bar for this vertical quad. Now for around the 4 corners, when we check from the left side, A bar and A will be cancelled out, so B bar will be there, and from top side C bar and C will be cancelled out and D bar will be there. So the resultant expression will be B bar, D bar. For this pair, from the left side it is A bar, B bar, and from top side C bar, D bar will be cancelled out, D bar will D. So A bar, B bar, C bar. And for this single one, the value will be A, B, C bar, D. So the resultant expression will be C D bar plus B bar D bar plus A bar B bar C bar plus A B C bar D. So we found out each term from the group and sum all the terms to find out the SOP form min-term expression. There is one more concept of don't care in KMap. The terms which will not affect the output. The presence of those terms whose value will not affect the output are considered as don't care. These don't care terms are inputted as X or cross in KMap. If we require this cross for grouping purpose, we will consider it as 1, otherwise we will consider it as 0. For example, for checking the physical significance, if we go for binary coded decimal range from 0 to 9, so we require 4 binary variables, but it will use only 0 to 9 combinations, and remaining 10 to 15 will be considered as don't care, because for decimal 10 to 15 is not a valid number. For decimal only 0 to 9 exist, and for coding 0 to 9 we require 4 binary variables. For 4 binary variables there is a combination from 0 to 15. 0 to 9 will be valid, whereas 10 to 15 will be very invalid, which will be considered as don't care. So what is the significance of these don't care terms? These don't care terms will help in grouping of min terms. If not required for grouping, don't care will be considered as 0 and left as it is, but if required for grouping, it will be considered as 1 and help the min term to form a larger group. So don't care terms will be considered if required for grouping, else it will be left as it is. So we will take one example of 4 variable KMap. How we will find out the 4 variable KMap? The largest term is 15, so it's a 4 variable KMap. The min term values are given as 1, 3, 5, 7, 9, and don't care terms are 10 to 15. First of all, we form the don't 4 variable KMap considering 2 variables on the left side AB and 2 on the top side, that is CD. Now we will input the terms 1, 3, 5, 7, 9 as 1. So 1, 3, 5, 7 and 9 are inputted as 1, and 10 to 15 as don't care. So 10, 11, 12, 13, 14, 15 are inputted as don't care. If we will not consider don't care, then there will only be one octet and one pair. But if we consider the don't care terms, then there is a group of 8 ones, that is a octet. So by considering don't care terms in the expression, we will be able to prepare or form larger groups which will calculate the expression in minimum form. We can also find out the expression, like for this equation, B bar and B will be cancelled out. So from left side it is A bar and from top side is a D, and for this pair it is B bar, C bar, D. So if we will not consider don't care, then the expression will be A bar D plus B bar C bar D. But if we consider the don't care terms and form the octet, then the final expression will only be Y equal to D. So we can easily see from this example how don't care term help to find the minimum sized expression. Now we will take one example of POS, product of sum term equation. It is quite similar to SOP. All the rules are same, but only 2 things are important. As we have already seen that for each min term in SOP we enter it as 1. For each max term, POS terms are called as max term. Max term is entered as 0 in the expression. Also in POS form, A means 0 and A bar means 1. That is, POS is just dual of SOP. We can say that POS is dual of SOP. So we will consider one example of POS form. Given POS form is represented as pi with a capital M. Consider one POS form 0, 2, 4, 6, 8 and don't care terms 10, 11, 12, 13, 14, 15. So we can easily see from this example that it's a 4 variable KMap. We form the 4 variable KMap A, B, C, D and enter these values 0, 2, 4, 6 and 8 are entered as 0 and remaining 10, 11, 12, 13, 14, 15 are entered as don't care. And as we form a group of ones in SOP, here we form the group of zeros in POS form. So we can see that around these extreme two corners there is a group of 8 zeros including don't care which form a octet and the resultant expression will be A and B all terms will be cancelled out. From the top 0, 1 that is C will be cancelled out and 0 that is 0 means D. So, Y equal to D. I hope POS form is quite clear, but we generally use SOP form most of the times in general representation because in real world all the problems A means 1 and A bar means 0, that is SOP representation. So, again I will explain that in POS form we cover all the zeros. Each sum term is entered as 0 and the final product of all sum terms is generated as the output. Again, don't care term is considered as 0 when it helps in the final grouping, else it will be not be considered in the expression. We take another example of a 3 variable KMap. If there is a min term expression 2, 4, 5, 6, 7, then the remaining terms are 0, that is max term. So, if the min term is 2, 4, 5, 6, 7, then max term will be 0, 1 and 3, that is remaining terms. So, we can easily group 0, 1, 3 in POS form. For this pair, the left side that is 0 that is A plus 0 that is B. So, A plus B and from top side C and C bar will be cancelled out. Again from this vertical group 0 that is A and from top side 1 that is C bar. So, this will be the resultant expression. I hope this is quite clear to all of you. Now, we move towards another KMap, that is 5 variable KMap. For a 5 variable KMap, the total number of terms will be 32, 2 to the power 5, that is 32, that is we move from 0 to 31. But it is quite difficult to manage such a large number of terms in a single KMap. So, we basically divide it into 2, that is we use 2 KMap of 4 variables, 16 into 2 that is 32. So, we prepare one KMap for 0 to 15 and another KMap for 16 to 31. For a 5 variable KMap, the MSB will be taken outside the KMap and for first KMap it will be considered as A bar, that is 0, and for second KMap it will be considered as 1, that is A, and the remaining 4 variables are entered within KMap. So, the KMap, each single KMap consists of 4 variables. Except MSB, the remaining 4 variables are within KMap, that is B, C, D, E, and the most significant bit, that is A, will be outside the KMap. For first KMap, A will be 0, so it is 0, 0, 0, 0, that is 0 to 0, 1, 1, 1, 1, that is 15. For second KMap, A equal to 1, so 1 and all 0, that is 16, and all 1, that is 31. So, for first KMap it is ranges from 0 to 15 and for second KMap It ranges from 16 to 31. So grouping will be same as we have already discussed in 4 variable KMap. That is, we search for first of all octet, then quad, then pair. But one more form of grouping is there when we put both these K-maps one over the other, and if there are ones or zeros on same location, then again it form a group. So we consider grouping in single K-map as well as put both the K-maps one over the other, and if we find any group one over the other, then again it will form a group of ones. For example, consider this example of min-term expression. The largest variable is 31. So we can easily say that it's a 5 variable K-map. We take 2 K-map. For first K-map A equal to 0 and for second K-map A equal to 1, and the remaining 4 variables will be entered within the K-map B, C, D, E. Now we enter all the terms, that is 0, then 4, 7, 8, 9, 10, 11, 16, 24, 25, 26, 27, 29 and 31. So we enter the given terms as 1 in the K-map. Now we check for the groups. For single K-map, if we cover these two K-map one over the other, these 4 ones and these 4 ones will form a octet. So there will be 1 octet. Now we search for quad. This group of 4 ones will form a quad. So there is 1 quad. There is one more quad, that is 1, 1, 1, 1 around the 4 corners. But this quad will not be this one, this one, this one and this one around the 4 corners. So there will be one more quad. Then there is a pair, that is 1 pair and a single one. So this is the overall pairing structure, that is 1 octet, 2 quad, 2 ones around the 2 corners, 1 pair and 1 single. According to this grouping, we can easily see that there are 2 quads more, but this is a redundant one because these 4 ones are already grouped in the octet structure. So now we can easily find out the expression, like for this quad, as we are taking from the both the groups, so A bar and A will be cancelled out. So the resultant value will be B C bar from the left side, and from top side all the values will be cancelled out. So for this octet the value will be B C bar. Now for this one around 4 the corners, again A bar and A will be cancelled out. So for this 4 ones it will be 0 and 1, that is B will be cancelled out, C bar. From the top side 0 and 1 cancelled out, that is E bar. So from the top these 2 ones and these 2 ones, from this value and this value 0 and 1, that is B cancelled out, C bar. From top side E bar and D bar. Now moving from this 4 values, B again 1 0, that is C will be cancelled out. From top side 0 1, that is D cancelled out, E and A. For this pair the expression will be A bar and from left side 0 0, that is B bar, 0 1 C will be cancelled out, D bar and E bar. And for this single one the value will be A bar, B bar, C, D, E. So the resultant expression consists of 5 terms: B, C bar plus A, B, E plus C bar, E bar, D bar plus A bar, B bar, D bar, E bar plus A bar, B, C, D, E. So this is the final expression of 5 variable KMap. Again we take one more example of a 5 variable KMap. It's quite similar to the previous one, only I will cover up the grouping, that is there are 4 ones on the denominator side, considering there is a group of 8, that is 1 octet. Then 1 pair, these 2 ones again and these 2 ones form one more pair and the 2 singles. So there will be 1 octet. 4 ones around the corner will form 1 quad. This. Then 1 pair, and this one will not get grouped from anyone. Similarly, this one will also not good. So 2 single. Now I will leave this example to you all, and you can easily find out the expression just like the previous example. So there will be 5 terms. 1 octet term will consist of 2 variables. 1 quad term will consist of 3 variables. 1 pair term will consist of 4 variables, and 2 single term will consist of 5 variables. So I will leave this video till this point and will continue up to next 6 variable KMap in next video. Thank you all.